Good afternoon, everyone, or good morning to our friends in the West Coast. My name is Cyril John. I'm the applications engineer for the southern part of the United States, and I will be your host for this webinar on SelectPlus. We will be focusing on the DHP selection process. And like I said, in addition to be the applications engineer, I'm also the project manager for our design software SelectPlus. So if through this webinar or when you are using it, if you are running into issues, I would definitely be the person to contact. Or if you have any ideas on how we can make the software better, I definitely greatly appreciate any input. We are doing monthly updates. So if you do have some ideas on making this product or software better, our goal is to make this as easy as possible for you and as user-friendly as possible. So again, thank you for taking your time out of your busy schedules to take part in this webinar. I hope that you'll find some of the tips and tricks that we do will make your selection process a lot easier, and you'll have a little better understanding of the product as well. Now, to get started, I wanted to talk a little bit about theory before we jump right into the selections. And since we're talking about dehumidification heat pipes, I wanted to just kind of go over the methodology of why we came up with this approach. Now, if you think about the brute force or old school approach of overcooling and reheating, you think about 80-degree air entering an oversized cooling coil. You need to dehumidify that air as much as possible, so you're dropping that temperature down to 52 degrees, 95%, just pulling down as much moisture as possible out of that air, so you're oversizing your cooling coil. Downstream, you have some sort of heating coil or reheat coil, electric heat, hot water, natural gas, to only take that 52-degree air to heat it up to 58 degrees, 65% RH, which ASHRAE 62.1 requires. So this process is extremely not energy efficient, and your costs are on both sides of your cooling process, not only by oversizing your cooling coil, but also the money you spend on to only heat up that air to get it to a nice 65% RH. Now, before I talk about the wraparound heat pipe, some of you may not be familiar with how a heat pipe actually works. Basic, simple process. In our case, it would be a copper tube filled with refrigerant. You have heat in that's on the bottom and heat releases on the top. And what's physically happening is we have a refrigerant in there that's changing phase from liquid to vapor. So as the heat is absorbed, that refrigerant is changing phase from liquid to vapor, and it's flowing up to the top of the heat pipe and releasing that heat. And when it releases that heat, it's condensing, and that process is starting all over again. It's completely passive. It's just using a temperature difference between the two ends of the heat pipe for that phase change to take place. So it's essentially a device that can move energy very quickly with the use of a refrigerant changing phase. Now we take that concept and we apply it to, we essentially wrap it around a cooling coil. So this first heat pipe coil we call here is actually our PreCool heat pipe, and the downstream side is our reheat heat pipe. So if you think back to the brute force method I just showed you, think about that same 80-degree air. It hits our first coil, which is called our PreCool heat pipe, drops that temperature down to 72. So now you're, instead of your cooling coil only seeing 80 degrees, now it's only seeing 72. Now you're leaving your cooling coil at 50 degrees, and that energy you captured upstream is going to be transferred downstream to the reheat heat pipe. So that 50-degree air is going to hit that second reheat heat pipe coil and heat up to 58 degrees. Like I said, this is a completely passive process. The two temperatures that are driving the system is the 80-degree outdoor air and the temperature of the air leaving the cooling coil. So the higher this temperature difference, the better temperature drop and temperature rise you'll have. The lower the drop and rise. So this is completely, like I said, a passive process. Now what's physically happening inside each circuit, like I said, there's a refrigerant in each circuit that we add, and that refrigerant is hitting that first coil, which is called our PreCool heat pipe, changing phase from liquid to vapor, flowing to the reheat heat pipe, and that reheat heat pipe is hitting that cool air from your cooling coil, so that's condensing and releasing energy in the form of reheat, and that process gets just that refrigerant that's condensed, flows back, and goes back to the PreCool heat pipe or the evaporator and starts that process all over again. So that's physically how it works. Now, to jump right into SelectPlus, which is our design software in which you can select this product, I want to come up with an example that obviously may not apply to everyone, but as long as you get the basic concept, this should help you get started on your selections. So just for an example, let's pick a job, New Orleans hotel. Let's assume this is a airflow, 100% outside air unit, 10,000 CFMs, 90/80 entering at design. I'm leaving my cooling coil at 5049.5. Let's say this is a hotel and this unit's actually feeding my hallway. So I'm looking for kind of a reheat to a neutral air temperature of about 68 to 72 degrees. My fin height and fin length is 50 inches tall and 70 inches long, so this should match what your cooling coil dimensions are, just something to keep in note. I designed this for about 400 feet per minute. That's typically common for 100% outside air units. Stainless steel casing, and I want to have some sort of corrosion protection coating, so I'm going to add electrofin coating, which you can do this all through the selection process. So let's jump right into it and go to the browser and go to the website. And let me sign out here so you can kind of see the process from beginning to end. So the website you want to go to is heatpipeselect.com. And now if you don't have a user account, I do have a colleague standing by that if you click here, just fill out the info and click request user account, he'll be able to approve your account so you can kind of follow along. If you already have a user account, I would definitely recommend that you try to follow along. This event will also be recorded as well, so we'll make sure it's available on the website if you miss anything. So let me go ahead and log in. And the first screen you see here is your dashboard, and this will be a list of all the projects you've worked on recently. You'll be able to jump right into the project by clicking the schedule button, and you'll go right into the selection process. But for this one, let's create a new project, and I want to go through those steps as well. So if you click My Projects, you'll see a list of all the projects you've worked on. Just a couple of tips and tricks for this page. If you're looking for a certain job, let's say I'm looking for the Marriott. If you type in Marriott there, you can actually pull that. So you have essentially a database of projects that you've worked on all in one place. But since this is a new project, let's go ahead and type in New Orleans Hotel and click Add New Project. Here's the project info screen. Here you'll be able to enter info about your project, the location, obviously New Orleans, Louisiana. If you're working with a certain representative, salesperson, engineering firm, this is really not any info that's required. It's more for, since you are creating a database, it's nice to have info that if you ever go back to a project, you already have all that info stored in one place. Now the defaults will have, you can select this, or you don't have to select this either if you don't have to select this. The bin location has to do with if you're doing an economic analysis. Let's say you're an engineer only working on projects in New Orleans. So if you select that, let's select Louisiana and pick New Orleans. Hit apply. And what this will do is anytime you create a new project, the location will automatically default to New Orleans. Now, if you're running an economic analysis in your selection, you always have the ability to change the location of your project, but this just gives you kind of a little shortcut. If you know you're going to work on 90% of your projects in one location, I would definitely recommend setting up some defaults so you don't have to keep changing the location every time. New Orleans being at sea level, or in some cases below sea level, I'm just going to choose an air type of standard with obviously no elevation. And the refrigerant that you'll most commonly use is R410A, which will be the default. I would say that's about 95% of what we do. If you're looking for more high temperature applications, like let's say above 150, between 150 and 200 degrees Fahrenheit, you want to switch to R134 because that's above 150 degrees. That's when R410A loses its phase change capability, and you want to switch to 134. But don't worry, you don't have to remember that. If you do enter a temperature above 150 degrees, the software will automatically prompt you to make that change. So let's hit update, which is here at the bottom. And you'll see that New Orleans Hotel is added to my project list. To jump into selection, you do want to hit schedule. Now here's your project schedule screen. You'll be able to view that project info again, add users to your project, and even submittals. I'll go over users and submittals in a couple minutes after I run through a selection with you. Now, the next thing you want to select is the product type. Today we're going to be going over the dehumidification heat pipe, so you want to select wraparound. If you are looking to select a heat recovery, so this is our standard side-by-side energy recovery heat pipe, you want to select a product type of heat recovery. But for this WebEx presentation, we're going to focus on the wraparound. And then click Add New Line. Now to start the selection, you want to select this button right here. It's a kind of a green paper with what looks like a hand pointing to it. And you'll see that it says Select Item. And this is your selection input screen. So this is where you'll input all your temperatures, your fin heights, your fin lengths. If you add coding, you can add that as well. So for the tag, let's just say this is HU1. Now for the type, we have two types of wraparound heat pipes. They both perform the exact same way. The only difference is the drawing will change depending on what you choose. So DHP U-frame is the default. So what that is, it's a wraparound that's fully enclosed in either galvanized steel or stainless steel casing. And what it is a very popular product that we can actually ship that to the air handler manufacturers to install in their unit at their factory. So it's kind of similar to the picture you see here on the right, where you have a system that's fully charged with refrigerant and just ready to slide right into your air handler around your cooling coil. Another type that we do is DHP-F, which is our factory install. This is a product where it's essentially the same thing, but this would involve the air handler manufacturer or the air handler actually coming to our factory in Tampa, Florida, and we would have our technicians physically retrofit the unit inside your air handler. Like I said, the only real difference is the drawing that you'll see later on. So for this example, usually systems this large, you'll typically send to the air handler manufacturer instead of the freight cost of sending it to Tampa, Florida. But we could do either method, it's up to you. But for this example, let's just stick with the U-frame. Our tubes we use is 1/2-inch copper tubes. You could choose between aluminum and copper fins. Let's just stick with aluminum for now. You can choose between 8 and 14 fins per inch. It'll default to 12. R410A or R134. Remember, for this project, we want to select electrofin coating. And you're also able to change the air type as well as elevation at this input right here. We also have the ability to have a controllable wraparound heat pipe. So what that involves is we actually add normally open solenoid valves to each individual heat pipe circuit. So if you are trying to control the amount of reheat or your leaving air temperature off the reheat heat pipe, you can actually add control valves, and what that will allow you to do is you'll be able to stage your performance. So if you're getting too much reheat, you can actually turn off one stage or two stages to control your reheat temperature. You can either select between 24 volt or 120 volt. You could change between 3 and 4 stages of control. So like I said, the valves we use are normally open. So if you did want to control it, you would just send a signal to your BAS, which is wired into a terminal strip next to our wraparound heat pipe, to turn off 1 or 2 stages so you can modulate your control that way. But for this one, let's just stick with this particular unit. Let's just keep it non-controllable. And this is where you would input your fin height. So your fin height is 50 inches. Your fin length is 70 inches. Your airflow is 10,000 CFM. 90, 79 is entering. And one feature I want to show you on the entering side is, let's say in this case, this is 100% outside air. But let's say if you have a mixed air unit, you actually have the ability to calculate that mixed air temperature. By just clicking this drop down and click Calculate Mixed Air, you're able to input the percentage of outside air or the outside air CFM, the return air CFM, and both temperatures, and the program will automatically calculate what your mixed air temperature would be. But for this case, since this is a 100% outside air unit, you don't have to do that calculation. But just in case if you need to, it's just this drop down and click Calculate Mixed Air. Now for the temperature leaving your cooling coil, this was 5049.5. So those are the two temperatures you need to calculate the performance of your wraparound. As you recall, the two temperatures driving the performance is your outside air and the air temperature leaving your cooling coil. You also have the ability to change instead of inputting a temperature, you can also input a capacity. So this is a popular thing to do if you're designing a DX system, and you want to actually calculate the leaving air temperature based on the performance of the pre-cool heat pipe. So instead of seeing 90 degrees, your cooling coil, let's say, will only see 80 degrees. So now with the fixed capacity DX system, you'll be able to even further dehumidify your air. You'll be able to get a lower leaving air temperature. But let's just assume for this job, this is chill water, pretty consistent leaving air temperature, and I'm just going to assume 50, 49.5. But that's just a simple drop down. If you did want to change between the two, you can as well. Here at the bottom, you're able to enter the span. Now the span is the distance between the inside or the leaving side of the pre-cool and the entering side of the reheat. There's going to be projects in which you want to have a large span between the two coils. If you have access sections in between, if for cleaning purposes, different things like that. So let's say for this job, I want at least 30 inches in between each coil, just so I can get in there and clean between the two. And you'll notice when we get to the drawing screen, the drawing will update with that 30-inch span. Now that span is a function of the fin length of the pre-cool, the span, and the fin length of the reheat. So we have a max circuit length, and the program will actually stop you depending on your fin length. Hey, this is the max span you can have with this fin length. So you'll get an error message. You'll see some prompt that says, hey, either reduce your span or reduce your fin length depending on that circuit length combination. So let's go ahead and click calculate. And you'll see that I'm pre-cooling my 90, 79 degree air down to 77.5, 75. So I'm actually almost condensing on the pre-cool heat pipe. I'm leaving my cooling coil at 50, 49.5, and I'm actually reheating about 13 degrees to 63, 55. Now, again, I'm looking for more of a neutral air condition. I wanted a little more, I'm looking more for like the 68 degree range. So let's go ahead and change the selection so that we can get that neutral air condition. So all you got to do is hit reselect, and let's increase this, let's say just up to a 4-row, and see what we get. Calculate. So we're getting 70 degrees. So we're getting actually about 16 degrees of pre-cool and 20 degrees of reheat. And the reason we're actually only getting, typically you'll see that most of the time those are the same. The reason we're only getting 16 degrees here is because we're actually condensing on the pre-cool side. So you can see that we're actually pulling out about 38 pounds per hour of moisture just with our pre-cool heat pipe, which is another thing to keep of note. The pre-cool heat pipe does have the ability to condense, especially with 100% outside air systems. If you're having a kind of a mild rainy day, this pre-cool heat pipe will condense. So you definitely want to make sure when you're designing your air handler that you have this under a drain pan. And it might be good practice to have the reheat under a drain pan as well, especially if you're planning on cleaning all the coils. Might be good practice just to have every coil under some sort of a drain pan. You can also look at the psychrometrics of this system by just clicking psychrometric chart. And you can see that we're taking that 90 degree air, cooling it down to 74, so we're hitting that saturation line. That cooling coil is dropping it from 74 to 50, 49.5, and we're heating it up to 70, 57.8. Now I'm going to go ahead and click continue. And here at the drawing screen, you're able to view the drawing of the selection you just made. So you can see that it's galvanized steel casing, and let's say for this example, I want it to be stainless steel. So I just click the drop down and click stainless steel. And you'll see that the drawing updated to stainless steel. The weight will also update as well. Let's say for some reason this has to fit through a door, or this is actually being installed on site, and this has to fit through a door. So 50 inches is a little too tall. It won't fit through my door, the section I'm trying to go in. I can actually click this drop down and change it. Let's say I want to make this as small as possible and click 3 sections. And the drawing will actually update and show 3 sections, 2 sections of 16.25 and 1 section of 17.5 to get your 50 inches overall fin height. So you do have some flexibility here at the drawing screen to modify your drawing to fit if you do have some restrictions in the field. Now, one of the prompts that you will continue to see with the DHP U-frame is the airflow direction. Now, in the design part of it, it's not very important to select an airflow direction, but if you are about to order the product, the airflow direction must be chosen. The reason is we slope our heat pipe circuits in the direction of airflow. So if I select a right airflow, you'll see that arrows have been added to the drawing. So if you're standing here with the air hitting you in the back of the head, just our hand what we use as handing, for this it would be a left-hand chill water coil, but in our case we do our piping around the U-bend side of your cooling coil. So for us this would be a right-hand coil or right-hand U-frame. So it's generally the opposite of what your handing is on your cooling coil. So something to keep in mind, if this was a left airflow for us, this would be a right-hand cooling coil for yourself. Again, in the design process, it's really not that important because the performance or price or anything doesn't change. It's just important when you are about to order to something to look at. Now, one feature I just want to highlight on this page as well that we actually recently added last week is this modified top and bottom flange dimension. That is requesting this. The flange dimension they want to match the top and bottom flange to the existing cooling coil. And now you have the ability to do this right on the drawing screen. You could just click Modify Top and Bottom Flange, and you can actually input a range between 1 and 1.5 inches, or 1.63 inches, I apologize. So if I type in 1.5 and click Update, you'll see that the drawing is updated with the flange height of 1.5 on top and bottom. So this is an easy way if you're trying to hit a certain overall height or you want to match your flange dimension. You could even do 1.54 if you like and hit update. If you're trying to hit a certain height, you can do that and the drawing will update accordingly. So that's a pretty neat feature that has been pretty popular with our OEM customers, that they now have the flexibility to change the flange dimensions on our U-frames early on in the design process. Now to save your selection, you want to click Save and Close. And here we go. We have our first air handler selected, air handler 1 with 10,000 CFMs right here in front of us. Now let's say for this job I have another air handler that's somewhat close. Let's say it's 9,750 CFM. All the other conditions are the exact same. And what I want to do, instead of hitting Add New Line, what I want to do just to save time is just click this button and click Copy To. What this will do is it will copy HU1 and it will add it to the second line. Now, you also have the ability for this Copy To feature to actually copy this line item to any project you have in the database. So if you're working on another hotel in New Orleans that's exactly the same or very similar conditions, you can actually just select that project and click Copy To. When you go into that project, Air Handler 1 will actually show up on that project as well. So that's a nice way if you are working on multiple projects that are somewhat similar with similar entering conditions, you have the ability to copy your selections to any project you have in the database. So for this one, let's just say, let's go back in and change this to Air Handler 2 and change this to 9,750 CFMs. Everything else stays the same. Actually, for this one, let's say this is located in a critical place and I want to control the reheat for this one. So what I would do is just select controllable. Let's say I want inline voltage, 120 volt, 4 stages of control, and click Calculate. It'll calculate the performance accordingly. Now, the next thing I want to show you is how to do economic analysis. You can do the economic analysis by right under the psychrometric chart button. There's an economic analysis button. Just click that. And you'll see that New Orleans, Louisiana is already selected. But for some reason, if you are working on another project in a different location, all you have to do is click here and select any state. You could even select Canada or any international as well. And you're able to just hit Apply. And what that'll do is it'll actually load up the bin data or weather bin data for that location. Now, the step 2 is your runtime hour. So this is actually a new feature that our old software, if you ever used that didn't have. where you're actually able to select exactly what your unit runtime is. So this is helpful if you're designing a wraparound for and you want to see the savings, let's say for a school, where they don't have the summer months, the unit running. So I want to deselect the savings for those months. You also have the ability, let's say if it's an office building, if it's only Monday through Friday, you can actually select the hours that your unit is running so you can get very accurate savings. So what it'll do is it'll actually modify the annual runtime based on your occupied hour runtime that you selected. So to load the bin data for this one, let's just say it's a 24/7 operation, keep it simple, and hit load bin data. And you'll see that the bin data for New Orleans has been added. Now, you'll notice at the top line, I have my airflow and my leaving air temperature for my cooling coil. So to drag this down, instead of actually physically typing it in every single row, I just click duplicate row, and that will actually copy the remaining, that design airflow and leaving air temperature off my cooling coil to the remaining bin rows. Now, the next thing I want to do is click calculate economic analysis. So this is the input screen that shows your savings summary, and you're able to input various rates for your cooling and your heating costs. So you can see what the actual savings would be with the wraparound. So let's say for this example, my electric rate is 10 cents per kW. And the type of heating I'm using is hot water, and let's just keep it at the default of $1.10 per therm. Let's keep my ER of, let's increase this ER to 17, and let's keep everything else default, my fan efficiency and my burner efficiencies. Now to calculate the savings, just click calculate, and you'll see the savings, the yearly savings, based on the rates you just selected. So you'll see the PreCool savings is about $4,000, almost $5,000. The reheat savings is $8,700. The only true cost of the wraparound is the statics. Being a completely passive system, the only additional cost that you have is pushing that air through the additional 2 or 3 rows of coils that you're adding to your around your cooling coil. Now the total heat pipe energy savings is just your PreCool, your reheat, subtract your static cost, and that's your total heat pipe energy savings. You can also calculate your payback or your return on investment. Let's say this is going to cost you, let's say $25,000. If you hit calculate, you can see my ROI for this system is 2 years. You'll also see another value shown here, something called recovery efficiency ratio. It's actually a calculation that you'll see if you ever read HRI Guideline V. It's a formula that's essentially energy recovered over energy expended in the recovery process. So it's kind of a measure of efficiency, the units being BTUs over watt hours. So in our case, we would take all the BTUs that we recover throughout the whole year and divide that by the watts or the fan power used to recover that energy. If it's another energy recovery device, let's say a wheel, you would take that same process, but now a wheel has a motor. You have to take into account the additional airflow that you have to push through for leaks and purge. So it really puts a true value of efficiency. So it's essentially calculating how efficiently your energy recovery device is recovering that energy. Again, for us, the only real cost is that fan power being a passive system. So let's go ahead and click continue. And save and close. All right. Now let's say I want to print the report for just AHU2. You could do that by just clicking this button here. It's kind of a bar chart. It's called View Reports. And you have report options here. So let's say you want to give your engineer or your customer some of the savings. Let's say you want to send cycle. Let's just say you want to send them everything just for AHU2. I would click check everything and click report. And I've always had this issue where people using the software earlier on, they have the pop-up blocker enabled. So for some reason, if you're not getting this page, just double check your pop-up blocker, make sure it's enabled, because it will open up on a new tab depending on your browser. Now you'll notice that another window opened up and you have your performance, you have your economic analysis, your psychrometrics, as well as your drawings. Now you can output this to PDF by just clicking this floppy disk and clicking PDF. Now this report will download to your browser. For Mozilla Firefox, it just downloads to the top corner. You center the screen, and I'm just going to open up the PDF, and here's the PDF of what we just created. So you have your design performance, your economic analysis showing your total savings with your rates here at the top, your RER, as well as your return on investment, your psychrometrics, as well as your drawing. Now this is just for air handler number 2. Let's say I had 10 air handlers, and I don't want to have to do this for every single one, click it every time and save it as 10 different PDFs. What you can do is click this submittal button and actually select what you want in that document. So what will happen, it'll actually take all your air handlers that you just selected and put it in one large PDF document with just a click of a button. So let's just say for this, I don't really want to see my bin analysis. Everything else, let's keep the same. And I'm going to click Save to PDF. And depending on the size of, let's say if you have a couple air handlers, it may take a little bit, but it is thinking. Just give it a second, and it should start downloading, depending on your internet speed. And it is taking a little bit. There we go. Sorry for the delay on that. As you can see, it's a 2.7 megabyte file. Let's say if you had 10 units, it could be potentially a 20, 30 page document. So here's your project submittal for both air handler 1 and 2. Let me make this a little easier to see. I'm going to make this 100%. All right, let's make it 80%. So you can see the pages here. This is my title page. The next page you'll see is your order code page. So on the top of every page, you'll see an order code for each air handler. And this is kind of a way to decipher what that order code means. So the fin height, fin length, you can all decipher that based on this order code sheet. So you have your design performance for air handler 1 and 2, with the only difference being the CFMs, psychrometrics for both, drawings for both. And you notice the drawing for air handler 2 is slightly different because this one we actually made controllable. So you can see that we have a removable access panel shown here to access the valve, as well as you have some pigtails that essentially goes into a terminal strip which sits in a NEMA box, which in turn wires into your building automation system. You have your control diagram for air handler 2. You can see the number of valves here. For this system, we'll have 24 valves, 4 stages of control. That's the inrush current required per stage, as well as the holding current. Remember, again, these are normally open valves, so this is the amount of current you need per stage to close those valves if you're looking to control them. This is the NEMA box we use, NEMA 3R, some details on the valves, Levada Electrofin coating, so details from Levada on the type of coating we use, as well as a warranty page. So you have a full-on submittal that you could just output just with the click of a button, just by clicking that submittal button. So I'm going to show you a couple more features, and then I'll just kind of open up the floor for questions, which you can ask in your chat window. I'm going to try to finish in the next 10 minutes, so I leave at least 15 minutes for any questions that you may have. So I'm going to click Return to Projects, and I want to show you a couple neat features. Jump right back into this project by clicking Open Schedule. Now, one feature that engineers will find quite useful is this Export Schedule feature. Now, if you click Export Schedule, what will happen is you'll open up in an Excel document. And it is opening as we speak. And here we go. We have a project schedule based on the selections you just made, both for air handler 1 and 2, showing both the pre-cooling heat pipe performance, your cooling coil, and your reheat heat pipe performance, all in one place. So if you had 10 air handlers, you just click the Export Schedule button, and this will output to a nice, clean Excel document. I've been told some engineers use features like Excel to CAD when they're creating their project schedule. So this is a pretty neat feature that you could incorporate in that process if you use it already. So that's a neat feature that some of our engineers were requesting for us to add. Now back at the project schedule screen, I want to show you this button called Users. So this is a feature that, again, SelectPlus is designed to keep a database of projects you're working on. Now it's your own personal project database. But let's say if you're working with the HPT representative or working with other colleagues in your office on a certain project, you want to have the ability to share that project with them. And you could do that by clicking Users and clicking the search icon. So let's say you want to share this project. Let's say you want to share this project with me. You would just type in my first name and click Cyril. There's not too many Cyrils in the database, as you can imagine. And click HPT Cyril. Here's my username, the company, and just select this button right here. You'll see that my username is automatically filled here at the top, and click Add New User. Now what will happen is when I log into my project database, it'll actually say New Orleans Hotel. So if you send me an email like, hey Cyril, can you take another look at this selection I just made? You could do that by just adding me as a user to the project. Now the permission level will automatically default to read only. So if you do want to change me to have the ability to edit your selections, all you got to do is click this edit button. And let's make me a project administrator. And click Save. And now that when I log in, I will not only be able to print your reports, I'll also be able to edit your selections if you would like me to. So a simple way, again, hit this search icon, first and last name. It's a simple feature. For some reason, if you don't know the username, just hit the search icon and you'll be able to find it that way. Now let me click back to schedule. And now if you wanted to delete line items from your selection, you could do that by just clicking this delete button, and it will delete that particular line item. If you have other handlers that got canceled from the project, you could just hit delete. Now one additional thing I want to show you before I open it up for questions is this help button up here. And you may find it very useful, especially early on when you're getting used to the software. You could do it, to learn more about the software, you can kind of do two things. We have a user manual here that you could definitely read through. It has quite a bit of information, as well as we have a section called tutorial videos. So if you click that, it's actually our own personal YouTube channel in which I actually add tutorial videos based on, hey, customer recommendations, or this feature is a new feature that we just added. And you can actually go to our YouTube channel and actually view videos on how to select certain items. So this is a video on how to customize DHP flanges. Again, this webinar was really focused on the dehumidification heat pipe, but if you're looking at selecting a heat recovery heat pipe, you can actually hit the HRM tutorials, and it's a 4-part video, all about 3 minutes long, and you can see that you can actually, it'll walk you through how to select an HRM. Currently we have about 20 videos on here, and we'll be adding case study videos, different videos about the software and what's going on in HPT. So I would definitely encourage you to check out that channel by just going to the help section. As well as if you had any additional inputs, like if you want me to make an improvement on a software, or if you see a potential bug, just input it here and click send, and I will definitely get back to you because this comes directly to me. Or you can also shoot me an email, and here's my contact info. If you do want to give me a call or send me an email, I'll be happy to reach you at that number or my email. I'll be happy to get back to you as soon as possible. Again, I'm going to open up the floor right now for some questions. I thank you for your time, and thank you again for using the software. If you do have some things we can make better, please let me know, and we'll definitely try to make that user experience much better.